What does it mean to eliminate? Good, get rid of. What's another word? Or another way to describe eliminate? Take away. What else? How else can you describe that word eliminate? Yeah, we got take away or take out. To remove, maybe? All right, one more way to say eliminate. Anyone else got another way to describe it? Cancel, maybe? All right, so if we have an amount and we add and subtract, to eliminate something when we're adding and subtracting, we want it to equal 0. In math, to completely eliminate something, we want it to equal 0, to get rid of it fully. All right, we have 2 examples, but then we are going to add in a couple reminders at the bottom. And then your quick check today is 2 problems. I have a headache. All right, here we go with number 1. So remember, we're still working with systems. Systems is how many equations this year? 6 equations at the same time? No, how many equations are we working with at the same time? 2 equations. And when we find an answer, what should our answer look like? What does a solution look like? X, Y. Good. We have 2 answers, X and Y. That was something I noticed on yesterday's practice, the ones that I graded. Some people only found X on that open-ended one. Remember, you had to find X and Y. All right. So here we go. Number 1, we have 7X minus 5Y equals negative 17. And our second equation we have is 9x plus 5y equals 1. Could I graph these equations? In order to graph, what would I need to do? Solve for y on both. Could I do substitution and solve for x or y? Yeah, but our problem is when I divide everything, am I going to get any nice whole numbers if I divide everything by 7? 5? No, can't do 17. What about 9? Can I do 1 divided by 9 nicely? Nope, 1 divided by 5? No. So this one would really be a pain to have to graph, or it would be a pain to have to substitute. We'd get a lot of fractions. And it's not that we can't work with fractions. It just makes it, we have to be really, really careful with what we're doing. So what we're going to do is we're going to eliminate, meaning we're going to get rid of either the x's or the y's. And to do this, we work vertically. Because this side is equal to this side, and this side is equal to this side, I can combine these 2 parts and these 2 parts, and it will remain equal. So we're going to work vertically, up and down. I'm going to draw a line across, meaning we're going to do the math up and down. And what part could I make 0 by adding or subtracting? The x's or the y's? Why are the y's? Good, they match. I have a negative and a positive. So I have negative 5 and a positive 5, and I want it to equal 0. So in order to get a negative 5 and a positive 5 to equal 0, should we add or subtract? Add. So you're just using one color pencil today. It doesn't matter which color, just one that's sharp so we can write with it. We're just going to kind of write our thought bubbles in that spot. So as I work my way across, as long as I add everything, everything will remain the same. So I'm putting that plus sign all the way across. And what are we trying to get rid of here? should be these y's, right? That's what's telling us what to do. That's how we knew to add. All right, so we add vertically. What is 7 plus 9? Not 19. No, it'd be 9 plus 9. 16. Good. So 16x plus, what's negative 5 plus 5? 0. So 0y equals negative 17 plus 1. Negative 16. Good. All right, I like to work my way horizontally across the page. That helps me on this problem. All right, so as I work on this, I'm going to rewrite this equation, but this time I'm going to write it without those y's. I have 0 y's. There's no need to have y's at all. So we're just going to have 16x equals negative 16. Oops, I forgot my x. 16x equals negative 16. All right, can I solve that equation? Yeah. So I need to get x by itself. How would I undo that multiplying by 16? Divide. Good. So if we divide by 16, that's good. If we do it on one side, we have to do it on the other side. So x equals, what's negative 16 divided by 16? We know 16 divided by 16 is 1. When we divide it by something by itself, it's 1. But then a negative divided by a positive is a negative. It's all right. We're getting there. All right. Are we done? No. Why? Good. We found the x. We need to find y. So to find y, what we're going to do is we get to pick which one of these we'd like to work with, and we're going to plug in that negative 1. So we get to pick one of the top equations, the originals, either 7x minus 5y equals negative 17, or we can pick 9x plus 5y equals 1. There's just whichever one to you looks easier. Which one looks easier to you, the top one or the bottom one? Yeah, the second one to me looks easier too because it's all positives. Okay, so now I'm going to write 9x. I'm just going to rewrite that equation first. 5y plus 5y equals 1. I like to just rewrite it first. That way I can visualize what's going to happen in this next step. So we have 9, and then instead of x, what are we putting in for the x? Yeah, negative 1. That's what we found for x. So 9 times negative 1 plus 5y equals 1. And what do we call that when we switch something out for its equal? Substitution. So this is elimination, but in the end, we still have to use substitution. And then we're going to solve that. That is our goal, to find out what y is. So 9 times negative 1 is negative 9 plus 5y equals 1. If you want to work ahead at this point, that'd be totally good. Get y by itself. So to get y alone, will we undo the negative 9 first or the 5? Do we undo the constant or the coefficient? Constant. Got the number with no variable. So negative 9, to undo the negative 9, we would add 9. Good. Both sides. If it helps you to cross things out, I noticed that yesterday. For some people, as they're working, they like to cross things out. Cross it out. Okay, bring down that 5y. 1 plus 9. 10. And to undo that, multiplying by 5. Divide by 5, both sides. Y equals 10 divided by 5. 2. So for our final answer, our solution, we'll go -1, 2, or 2, -1. Good, -1, 2, because an ordered pair always goes x, y. Good. Okay, still feels like a lot of work. I'm not going to lie, it is. It's still a lot of work. But it's less work than if we tried to graph it, and it's less work if we try to use substitution for the whole thing. Okay, goes by a little bit faster. All right, number 2, we have one more problem, and then we're going to make a note to ourselves at the bottom about when to do what. And then 2 problems on your quick check today. Yep, last problem, but we're going to add in some information on it. So, number 2, we have -4x minus 3y equals 18. And -4x minus 4y equals 16. This one substitution could be easy to do. We could solve for x or y on this bottom one. But we're just practicing our substitution, or our elimination here. So first thing I'm going to do is identify which one are we eliminating. Are we going to try and get rid of the x's, or are we going to try and get rid of the y's? Which ones match? X's. Yeah, we want something either matching or something that's opposite. So we have -4 and -4. So off to the side here in my colored pencil, I'm going to write that out so I remember. I'm doing -4. And then I'm going to leave a little space for that add or subtract, -4. And I want it to equal 0. So if I have -4 and -4 to make it 0, do I want to add them or subtract them? Yeah, if you're not sure, you can plug it into your calculator. If I have -4 plus -4, that would equal -8. If we subtract, we get 0. How did you know subtract, Omar? You just knew it? Good. All right, so we're going to subtract. If we do it on one part, we're going to do it to all the parts. So subtract, subtract, subtract all the way across. All right, we just did that first one. -4 minus -4 is 0. So we get 0x plus. Now we're going to do this next one. I have a tough time when there's so many negatives, so I do like to use my calculator for this one. -3 minus, that's the orange minus, -4. -4. And we get out 1. So 1y equals 18 minus 16. Should get 2. All right, I'm going to rewrite that equation so it doesn't have the x's. We eliminated the x's. The x's are gone. There's 0 of them, so we can just write 1y equals 2. What's 1y really equal to? How else could I write 1y? Just y equals 2. If you didn't know that, though, you could solve it. How would you undo it? Multiplying by 1? Dividing by 1. And you can use this line for division, or you can do that little dot dot. Divide by 1. 2 divided by 1 is 2. Either way, we get the same thing. All right, now at this part, we get to choose which one we would like to use. Either this top equation or this bottom equation. It's up to us. We get to have that decision. So do we want to use the top equation, -4x minus 3y equals 18, or -4x minus 4y equals 16? And the last one we used the bottom equation, so should we switch to the top equation this time? Just to show that we can do either. So let's do negative 4x minus 3y equals 18. I like to just rewrite it first and then fill in what we know. And if we're going to put 2 in, do we put 2 in for the x or 2 in for the y? Where is that 2 going to go? Why? How come? Because y equals 2. It says y, so good. So negative 4x minus 3, and we'll put parentheses 2, equals 18. And our goal is to solve that for x. So we're going to multiply 3 times 2 first. Simplify this side. So negative 4x, what's 3 times 2? 6. So minus 6 equals 18. At this point, it's that two-step equation. You should be able to feel like you can kind of work ahead on this. Are we going to undo the negative 4 first, the coefficient, or undo the constant, the negative 6? The constant. We always start with that constant, that number with no variables, so that minus 6. How do we undo minus 6? Add 6, both sides. Beautiful. Okay, again, if that helps you to cross it out, cross out that negative 6. All right, this negative 4x gets dropped down. So that's still there. The 6's are gone. And then we actually have to add 18 plus 6. Anyone got that for me? No? Okay, 24. Cool, crushing it. All right, last step now is to undo that negative 4. Are we going to add 4, subtract 4, multiply by 4, or divide by 4?
Divide by 4.
Divide, good. And I said it wrong. What are we actually going to divide by?
Negative 4.
Negative 4, good. And again, I'm using that fraction line for division, but you can use that little line with the 2 dots. All right, 24 divided by negative 4, negative 6. All right, so for our answer, we write it out as a solution. Solution is an ordered pair. What do you got, Gavin? What's our solution going to be?
Negative 6, 2.
Beautiful. Negative 6, 2. What made you choose that order?
X goes first.
Good. X goes first. All right, we have one more thing to add, so don't put away your computers. Don't put away your notebooks yet. We are going to check our solution really quick, because sometimes it gets lost and like we're just doing math to do math. Remember, our goal is if I take that negative 6, 2, and I put it back in our equations, they should make it true. So I have negative 4 times, what did we say our x was?
Negative 6.
Negative 6 minus 3 times, what's our y? 2. And we wanted that top equation to equal 18. Does it equal 18? Yep. Okay, bottom equation, negative 4 times, what's our x? Negative 6 minus 4 times, whoops, that won't work, minus 4 times 2, and we want it to equal 16, did it? Yeah, my calculator's a little fuzzy today, I don't know why. All right, at the bottom here, we're going to make a little note to ourselves about when to add and when to subtract. Okay, so I'm going to do a little like separate amount here. Okay, because that can be the toughest part about this is knowing when you're adding and when you're subtracting. If they are the same coefficient, if they're the same coefficient, coefficient's that number next to the variable. So if I have like 5x and 5x, how would I get that to be 0? We would subtract. Good. Well, that was a crazy subtraction sign. We're so close to being done with notes because this is like probably one of the most important parts to write down today. It's literally this. So do you want to write this down first? All right, even if I have negatives like negative 3y and negative 3y, when they're matching, they're the same. They're both negative 3. What are we going to do? We still subtract. So that's the part that can be really confusing is when they're the same coefficient, that tells us to subtract. When they're completely matching, we subtract. Write this down. All right, when do we add then? When they're not, well, they kind of match still, but they're good. They're opposites, a positive and a negative. So if I have opposite coefficients, okay, like I have a 4x and a negative 4x, or I have a negative 8y and a positive 8y, and I need to get to 0. When they're opposites, are we going to add them or subtract them? We add them.